So if two polygons are similar, if the corresponding angles are congruent, which means they have the same size and shape, and the length of the corresponding sides in proportion, called the scale factor. We'll talk about scale factor tomorrow. So let's look at these two triangles and see if they're proportional. So I have to set up see if they're similar. So in order to do that, I'm going to set up a proportion. But before I do that, I'm going to identify my corresponding side. So this side over here, well, it's a 90-degree triangle, right? So the side opposite the 90-degree angle is called the hypotenuse, which matches with this guy over here. The 35, right, 35-degree angle is 32 here, which this. That's this, and then the 35 matches with this. The 20 matches with 32, and this matches with this. Now, I don't think they're similar, so I'm going to take, here's triangle 1, this triangle 2. I'm going to take two sides, two sides. Let's take 40, 32. So the ratio of 40 to 32 is going to be the same as in the other triangle. And the 40 corresponds to the 25, and the 32 in this triangle corresponds to 20. If you cross multiply, you can, which is probably the easiest way to see if they're proportional, similar or not. Sorry, I keep using that word. 800. And 32 times 25, my tooth, is also 800. So this obviously is, these two triangles are similar. Just whoever drew this triangle, I don't think they did it correctly. But anyways, are the following rectangles similar? So again, this corresponds to this, right? And this side obviously corresponds to this. So the angles are the same. So remember, the angles must be the same. And if the sides are proportional, then it's similar. So rectangle 1, rectangle 2. In rectangle 1, we're going to do the ratio between AB and AD, right? Those two, 1836. And that should be the same as the ratio of 25 to 45. Oh, God. So if you cross multiply, you get 18 times 45, which is 810. And then if you cross multiply 25 times 36, you get 900. So these are not similar. These two rectangles are not similar. Are the following triangles similar? Well, let's identify the corresponding sides first of all. So this 34 is opposite the 9-degree angle, and the side that's opposite the 9-degree angle, right? Look at that, 17. So these two sides are corresponding sides. The side opposite 60-degree angle is 30, so I'm going to put two lines here. And this smaller triangle, this side opposite 60 degrees, 15, so that's 2. And obviously the last one, I'll put 3. So triangle 1, triangle 2, now that I identify the corresponding sides, I'm going to take the ratio of 34 to 30. Should be the same as the ratio of 17 and 15. You can obviously tell that this one it is, because if you divide this by 2, we don't even have to cross multiply. Divide this by 2, 34 over 30 becomes 17 over 30. So that, if you want, and I'll just cross multiply just to 510, and 30 times 17 is also 510. So because they are similar, okay, and sorry, they are similar, so we can write that triangle TPN is similar to triangle GKR. Okay. All right, so that's the easy. Now we get to use that proportion, right? If it states that the two shapes are similar, then the ratio of the sides in one shape is equal to the ratio of the sides in the other shape. So first things first, I think you all should always identify who corresponds. So SR is VW on the other one, and X, the two lines, corresponds to this, right? Those two are the matching sides. So this is quadrilateral 1, quadrilateral 2. So in quadrilateral 1, I'm going to say 35, the ratio of 35 and X is the same thing as the ratio of 25 and 15. You can cross multiply. There's several ways of doing this. If you don't want to cross multiply, let's say you simplify this to 5 over 3. Then you can easily just see the relationship. It's times 7 times 7, so X would be 21. If you decided to cross multiply, let me just write it again, 35 over X, 25 over 15. I mean, you get 25X equals 35 times 15, which is 525. Divide both sides by 25, and X equals 21. You get the exact same answer. Okay. 2, again, it tells you that they're similar, right? It's telling you it's similar right here. And if they're similar, their angles are exactly the same, and the sides are proportional. So obviously this 54 and this 42 matches, and then this X and this 28 matches correspond. So let's do those two first. Let's find X and then we'll find Y. So let's call this triangle 1, triangle 2. In triangle 1, we go X, the ratio of X to 54 is the same as the ratio of 28 to 42. We could, I probably go on the route of simplifying this and then finding a relationship because I can see that there is one. Or if you don't want to do that, we might as well cross multiply. 42x, 54 times 28 is 1,512. Divide both sides by 42. And we get 36. So x equals 36. So I'm going to go back to this picture and write 36 over here. So that's one. And then now I have to find y. So with y now, triangle 1 again, triangle 2. I'm going to use, you can use 36 in y or 54 in y. It's really up to you. So let's use 36 because we just found it. So 36, the ratio of 36 to y is the same thing as the ratio of 28 to 35. Again, this one, I'll simplify. If you divide this by 7, you get 4. Divide this by 7, you get 5. So now clearly, it's 4 times 9. So here would be 5 times 9. So y is going to be 45. So, okay. So it's, again, guys, there's not much to this, unfortunately. It gets a little bit, we did this, so I'm not going to do it. Maybe with question like 6, 5, you have to like be a little bit more careful. But besides that, everything else really simple. So let's go to 4 over here. So we have a triangle with size 3. Okay, so it's an equilateral triangle. So that's 6, and this is 3. And then we want to make it a little bit bigger. And it's telling us that the shortest side of the new triangle is 13. So this, all right, so obviously this and this are corresponding, these two and these two correspond to each other. So you can write x. This is also x because they're equilateral. Sorry, equilateral, no, isosceles, sorry. Let's write the ratios, set up the proportion. So in triangle 1, we're going to use the ratio 6 to 3, right? The same as the ratio of x to 13. Cross multiply, we get 3x equals, no idea, 13 times 6 equals 78. We divide by 3, and x equals 26. Okay, so if this is 26, this is 26. Again, it says that they're all similar. Find the missing sides, missing length, I'm sorry. So the hypotenuse 25 corresponds to this one. The x corresponds to this one. So I'll put one line. Set up your proportion. So triangle 1, triangle 2. X to 25, right? The ratio of x to 25 is the same as the ratio of 6 6 to 10. If I simplify this, divide by 2, this is 3. Divide by 2, this is 5. Look how much easy that is. Times 5, and this is going to be times 5. So x equals 15. Same thing here. The hypotenuse, which is 50, which is the side opposite the 9-degree angle, corresponds to this. And the 40 and the 20 are corresponding. So set up a proportion. T1, triangle 1, triangle 2. Triangle 1, it's, let's write hypotenuse over the leg here, 50 over 40. On the other side, let's go hypotenuse over 20. Well, so this one, we're going this way, right? 40 go to 20 is divide by 2. Divide by 2, so x is going to be 3, they want 2 on the side. So, well, okay. So hypotenuse was hypotenuse. Leg. So this guy over here corresponds to this, and this one corresponds to this. So let's find x first. So to find x, let's do triangle 1, triangle 2. Triangle 1, let's do 34 is 230, right? 34 is 230, so I'm going to use x, which is the hypotenuse. X is 2, and the 30 matches with the 15, so there you go. This one is pretty easy, guys, because look, it's just divide by 2 and divide by 2. So this should be x equals 17. So if you notice, everything, all the sides are going to be divided by 2. We don't even really need to do the other one. So 16, this is going to be 8 in the smaller triangle, right? Question 4. Again, let's identify our triangle. This y here comes up with a 5. 14.4, the 2 lines matches up with a 12, and the x 1 to 3 line corresponds with a 13. So triangle 1, triangle 2. Do we have? Wait, we have 2 things. So let's do x to 14.4. I can't do x over y because then I do have 2 unknowns. So x to 14.4. So x, of course, is the 13 on the other triangle, and the 14.4 matches up with the 12 in the other triangle. So now this one I'm going to cross multiply. I get 12x equals, what is that? 14.4 times 13 equals 187.2. We're going to divide both sides by 12. And x equals 15.6. So this, I'm going to come over here and write 15.6. I'm going to set up another proportion to find y. So I'll do it on top here. T triangle 1, triangle 2. And let's do y over, I don't know, the value we just found, 15.6. That sounds fine. Doesn't matter which one you use. You could have used 14.4. So the y corresponds with a 5, right? And the 15.6 in the big triangle matches up with the 13, corresponds to the 13. Cross multiply, 13y, and then 15.6 times 5 is 78. Divide both sides by 13, and y looks like 6. So this guy is 6. So you have to do 2 sides instead of 1. That's the thing. For 5 and 6, my suggestion to you guys is to draw them out separately. So there's 2 triangles in here, so I'm going to pull out the first one. The first one, this is 6 and this is x, okay? And the second one, which is the bigger triangle, this is 15, and this side over here, it's obviously 6 plus 4, which is 10. Much easier to see. This corresponds, and this x corresponds to 15 on the other triangle. So now, just set up your proportion. So 6, ratio of 6 to x is the same thing as the ratio of 10 to 15. Probably cross multiply here. 10x, 6 times 15 is 90. Divide both sides by 10, x equals 9. Done. Same thing here. I'm going to pull out the small triangle. Here it is. That's the 3, that's the 4, and that's the 5. Now the bigger triangle. This side they call x, the whole thing they call x. This is 12.5. And the height here, we don't have the height. Well, do it. They're not asking for it. Okay, so we're not gonna find the height. We're just gonna find the base here of the triangle. Okay, so this matches with this, corresponds with that. This base here corresponds to this, and that's all I need to find my missing value, which is x. So the ratio of, and again, I'm not going to use 3, of course, because we don't have this value. So let's use 5 to 4. So the ratio of 5, right? 5 to 4 is the same thing as 12.5 to x. Cross multiply, we get 5x equals 50. This hurts. Equals 50. Divide by 5. Divide by 5. X equals 10. So this guy here is 10. Okay. Yeah, that's it. A giraffe is 18. Okay, so let's draw the giraffe. So giraffe. Or not. The giraffe is 18 feet tall and has a shadow of 12 feet. Here's a shadow. Corey is tiny. He's 4 feet tall. No, sorry, he has a shadow of 4 feet. Right? And we don't know his height. There we go. So the sun is here, right? So if you think about it, here's the sun. So it's, let me move the sun a little bit. So at this particular time, right, there's your, right, actually I should say it like this and like this, right? We don't want the hypotenuse, we just want the height of Corey, so we can set the proportion. So 18 over 12, same as x over 4, so we can cross multiply, but I hope you see that we don't need to here. This is times 3. Sorry, I'm going to go the other way. Divide by 3. This is divide by 3. So x equals 6. Corey is 6 feet tall. We have a Ferris wheel. Ferris wheel. Okay. Yeah, I don't like to go on these. Has a shadow that's 20 meters. Guess we don't know the height of the Ferris wheel. We have a man standing right here, and he's 1.8 meters tall, and his shadow is 2.4 meters. So what, well, yeah, I guess we'll find the height of the Ferris wheel. So there is your proportion right there. X over 20 equals 1.8 over 2.4. 2.4, sorry. So it's cross multiply, we get 2.4x equals 20 times 1.8, which is 36. We're going to divide both sides by 2.4. And x equals 15. So the height of the Ferris wheel is 15 meters. Okay? Still not going on it. 9. Flagpole has a shadow. As long as you draw it, it becomes very easy. Here's a flagpole. Right? Has a shadow of 28 feet. Very long shadow. Person standing by has a shadow of 8 feet. Person 6 feet tall. How tall is the flagpole? X over 28, right? The ratio of these two in this triangle is the same thing as the ratio of the other one, which is 6 over 8. Can we find a relationship? Yeah, we can. So if you simplify 6 over 8, you actually get 3 over 4. So to go that way, it's times 7. And this one is times 7. So x equals 21. So the flagpole is 21 feet tall. Photograph. Okay, so 3 more problems. Okay, so we have a photograph 4 inches wide and 5 inches tall. Okay, inches and inches. Now we want to make a mural where the width is going to be 120 inches. How long is the mural? So there is your what do you call your values? Well, I haven't been doing this, but this obviously is this, and these two correspond to each other. So the ratio of 5 to 4 is going to be the same ratio as x to 120. Cross multiply, we get 4x. 120 times 5 is 600. We're going to divide that by 4, and x equals 150. 9-foot ladder. Okay, so we have a building. Well, let me draw the building. Alright, so here's a building with doors and windows. And there's a 9-foot ladder leans against the building. 6 feet above the ground. So there's a ladder. And this guy right here leans 6 feet. This is 6 feet. Okay, at what height would a 15 9-foot ladder? Oh, the ladder is 9 feet. Okay. And then at what height would a 15-foot ladder? So same building, right? What height? So the 15-foot ladder is over here. This is 15. This angle is the ground the same, so this angle, and I'll put a little thing for angle, is the same angle. And what height would the 15-foot ladder touch? So we're missing this guy right here. So set your proportion. 9 over 6, 15 over x. Cross multiply, we get 9x. 6 times 15, which is 90, divided by 9, divided by 9, x equals 10. Okay? Sorry. One more question. I think it's the last one. Chris wants to reduce a triangular pattern with sides 16, 16, and 20. Okay, that's 20. Not drawn to scale, by the way, 16 and 16. If the longest side of the new pattern is 15 centimeters, so we can reduce this not by much. What are these two sides? Right. Okay, so this corresponds to this. So now, it's proportion, so we can say 16 on triangle 1. Let's try 2. So on triangle 1, 16 to 20. The ratio of 16 to 20 is going to be the same ratio as x to 15. Cross multiply. 20x. 16 times 15 is some number that I now know. It's 240. We're going to divide by 20. Divide by 20. And x equals 12. All right, very repetitive, very, very repetitive, I know, but I guess that was today's task. That's it.